Welcome to Schroeder's classes. Today we'll be dealing with quantum numbers and uncertainty principle. Now, before beginning, let us see what a quantum number is. Quantum numbers are nothing but a set of tools which is used for complete description of an electron. That is, quantum numbers are nothing but numbers which provide complete description of an electron. These are four in number, namely 1, the principal quantum number, the Azimuthal, it's the name of the scientist, quantum number. Okay, I'll also write the symbols used for each. This one will be L. I'm sorry. Yeah. Thirdly, it's the magnetic quantum number, which we usually denote by M1, and lastly the magnetic spin quantum number, which we generally designate as MS. These are the four quantum numbers that are usually needed. These all quantum numbers also help in designating the electron present in an orbital. Further, since an orbital can contain a maximum of 2 electrons, from Pauli we had seen that, with opposite spin, an additional quantum numbers known as the magnetic spin quantum number MS is required to specify the spin of the electron. This quantum number, unlike the above 3 quantum number, is not derived from the solution of the Schrödinger wave equation for hydrogen atom. Now, the magnitude of the spin angular momentum, let me write this down first. Yes, angular momentum of an electron is root over s into s plus 1, this whole term, into h by 2 pi, with spin quantum numbers as s equals to half, that is nothing but root 3 by 4 pi whole into h. Spin angular momentum is a vector quantity and can have only two orientations relative to a chosen axis. Now on the screen we have a very special and a very important stuff. This shows the quantum numbers and their significance. First is the principal, where electron energy level or shell number. It has possible values of 1, 2, 3, and its significance is it identifies shell, determines size, number, and energy of orbital. Number of orbitals in the nth shell, which is equals to ns square. Next is the azimuthal quantum number, which is L, positive integer less than n. It has orbital type of s, p, d, and f. Possible values ranges from 0 to n minus 1. Total possible values is thus n, and it identifies the subshell. I'll write this down. Identifies the subcell. Next is the magnetic, which is the orbital subtype. The integers between minus L to L has its restrictions, and thus integers minus L, L plus 1 till L minus 1 to L are given. The significance is that it determines the orientation of the orbital. So let us first write this down, that is orientation. And lastly, the electron spin or the magnetic spin quantum number, which has numbers minus half plus half and determines the orientation of the spin. Spins in any single suborbital must be paired. Thus, you will notice a sign of this in each orbitals. Next, we need to note that spin is purely a quantum mechanical property. That is, it differs from its classical namesake.